FortiGate Infrastructure Routing. FortiGate Infrastructure Routing. We will see in this lesson routing on FortiGate, routing monitor and route attributes, equal cost multipath routing, reverse path forwarding, best practices, and the diagnostics. We will see the objectives, identify the routing capabilities on FortiGate, configure static routing, implement policy-based routes, control traffic for well-known internet services. What is IP layer routing? Rating is how FortiGate in NAT mode decides where to send the packets that it receives and the packets that it generates. All network devices that perform routing have a routing table. A routing table contains a series of rules. Each rule specifies the next hop, which may or may not be the final destination of the packet. Each routing hop in the routed path requires a routing table lookup to pass the packet along until it reaches the final destination. When routing packets, FortiGate will first find a matching route in its list of routes based on the packet's destination address. When performing this match, FortiGate evaluates the entire routing table to find the most specific match before selecting a route. If FortiGate finds multiple matches, it uses various route attributes to determine the best route. Proper routing configuration is important. If routes are misconfigured, packets will not reach their destinations and will be lost. By default, many aspects of FortiGate are stateful. That is, FortiGate decides many things at the beginning of a session when it receives the first packet. For each session, FortiGate performs two routing lookups for the first packet sent by the originator, for the first reply packet coming from the responder. After completing these two lookups, FortiGate writes the routing information to its sessions table. Subsequent packets are routed according to the session table, not the routing table. So all packets that belongs to the same session follow the same path, even after a change in the static routes. However, there is an exception to this rule. If there is a change in the routing table, FortiGate removes the route information for the session table. Then it makes additional routing table lookups to rebuild this information. Configured manually by an administrator. One type of manually configured route is called a static route. When you configure a static route, you are telling FortiGate, when you see a packet whose destination is within a specific range, send it through a specific network interface towards a specific router. You can also configure the distance and priority so that FortiGate can identify the best route to any destination, matching multiple routes. You will learn about distance and priority later in this lesson. For example, in simple home networks, DHCP automatically retrieves and configures the route. Your modem that sends all outgoing traffic through your ISP's internet router, which can relay packets to their destination. This is typically referred to as a default route because all traffic not matching any other routes will, by default, be routed using this route. The example shown here is the default route. The destination subnet value is 0.0.0/0.0.0 will match all addresses with any subnet. Most FortiGate devices deployed at the edge of the network will have at least one of these default routes to ensure internet traffic is forwarded to the ISP network. Static routes are not needed for subnets to which FortiGate has direct layer 2 connectivity. Static routes with named addresses. If you create a firewall address object with the type IP or netmask or first qualified, fully qualified domain name, you can use that firewall address as the destination of one or more static routes. First, enable static route configuration in the firewall address configuration. After it is enabled, the firewall address object becomes available for use in the destination drop-down list for static routes with named addresses. Dynamic routes. For large networks, manually configuring hundreds of static routes may not be practical. Your FortiGate can help by learning routes automatically. FortiGate supports several dynamic routing protocols, RIP, OSPF, BGP, and ISIS. In dynamic routing, FortiGate communicates with nearby routers to discover their paths. To advertise its own directly connected subnets, discovered paths are automatically added to FortiGate's routing table. So verify that your neighbor routers are trusted and secure. Larger networks also may need to balance the routing load among multiple invalid paths and detect and avoid routers that are down. You will learn more about and all these lessons. Policy-based routes. Static routes are simple and are often used in small networks. Policy-based routes, however, are more flexible. They can match more than just the destination IP address. For example, if you have two links, a slow one and a fast one, you can route packets from low priority source IPs to the slow link. Policy routes set to the action, forward traffic have precedence over static and dynamic routes. So if a packet matches the policy route, FortiGate bypasses any routing table lookup. Like static routes, policy-based routes must be valid. A destination and a gateway are required. And disconnected interfaces can't be used. For policy-based routes, packets must also match all specified subnets. 2 bits and port number. So if you don't want a setting to be included in the matching criteria, leave it blank. Policy routes are maintained in a separate routing table by FortiGate and have precedence over the regular routing table. Policy-based routing actions. When a packet matches the policy route, FortiGate takes one of two actions. Either it routes the packet through the configured interface and gateway, bypassing the routing table, or it stops checking the policy routes. So the packet will be routed based on the routing table. Remember, for a policy route to forward traffic out to a specific interface, there should be an active route for that destination using the interface in the routing table. Otherwise, the policy route will not work. Internet service routing. What happens if you need to route traffic to a public internet service, such as Dropbox or Apple Store through a specific band link? Say you have two ISPs. You want to route Netflix traffic through one ISP and all your other internet traffic through the other ISP. To achieve this goal, you need to know the Netflix IP addresses and configure the static route. After that, you need to frequently check that none of the IP addresses have changed. The Internet Service Database helps make this type of routing easier and simpler. ISDB entries are applied to static routes to selectively route traffic through specific WAN interfaces. Even though they are configured as static routes, ISDB routes are actually policy routes and task precedence over and other routes in the routing table. As such, ISDB routes are added to the policy routing table. IPv6 routing. To enable routing configuration for IPv6 addresses using the GUI, you must enable IPv6 in the feature visibility menu. Then you can create static routes and policy routes with IPv6 addresses. Enabling the IPv6 feature or also enables GUI configuration options for IPv6 versions of the dynamic routing protocols. Which of the following objects can use to create static routes? ISDB objects. What is the expected behavior when the stop policy routing action is used in a policy route? FortiGate will route the traffic based on the regular routing table. Routing monitor and route attributes. Interpret the routing table on FortiGate. Identify how FortiGate decides which routes are activated in the routing table. Identify how FortiGate chooses the best route using route attributes. Routing table monitor. The routing table monitor on the FortiGate GUI shows the active routes. Which routes besides the static routes are displayed here? The directly connected subnets. When a subnet is assigned to FortiGate's interface, a route to the subnet is automatically added with connected shown in the typed column. For connected routes to be displayed, the respective interface link must be up. This means that if an interface is down or there is no link established, the route will not be added. Dynamic routes. On larger networks, your FortiGate may receive routes from other routers through protocols such as BGP or OSPF. FortiGate will add these routes to the routing table with the respective routing protocol's name under the typed column. Which configured routes are displayed in the routing table monitor? Inactive routes. If an interface is administratively down, has its link down, or its gateway has been detected dead by the link monitor feature, then the route is considered inactive and will not be added to the routing table. Standby routes. These are the valid duplicate routes that have the higher distance. For instance, a second default static route with a higher distance. A dynamic route such as BGP, RIP or OSPF to the same destination or another static route. However, the dynamic route is not displayed in the routing table because the static route has lower distance. Policy routes are viewed in a separate table. ISDB routes are also added as policy routes in the policy route monitor. A routing monitor. The routing monitor provides extended route lookup for the routing monitor. This feature checks for both policy routes and the regular routing table. If the route matches the policy route, then you will be redirected to the policy route page on the guide. In the route lookup, you can specify the destination address and after you specify the destination port, source IP, protocol, and source interface to search route based on these criteria. Route attributes. Each of the routes listed in the routing table includes several attributes with associated values. The network column lists the destination IP address and subnet marks that will be matched. The interface column lists the interface that will be used to deliver the packet. The distance, metric, priority attributes are used by FortiGate to make various route selection decisions. You will learn about each of these later in this lessons. Distance. Distance or administrative distance is a number that is used by routers to determine which route is preferred for a particular destination. If there are two routes to the same destination, the one with the smaller distance is considered better and used for routing. The routes with higher distances are not installed in the routing table. By default, routes learned through the RIP protocol have a higher distance value that routes learned through the OSPF protocol. OSPF is considered to be more accurate than RIP. The following values are the default distances on FortiGate. 0 directly connected, 5 DHCP gateway, 20 external BGP routes, 200 internal BGP routes, 110 OSPF routes, 120 RIP routes, 10 static routes. The metric attribute is used to determine the best value route to the destination when dealing with routes learned through dynamic routing protocols. If two routes have the same distance, the metric value is used to break the tie. The route with the lowest metric is chosen for routing. How the metric value is measured depends on the routing protocol. For example, RIP uses the hop count, which is the number of routers the packet must pass through to reach the destination. OSPF uses cost, which is determined by how much bandwidth a link has. When multiple static routes have the same distance value, they are both installed in the routing table. So which route will be used to route matching packets? In this scenario, FortiGate uses the priority value as a tiebreaker to identify the best route. Routes with lower priority are always preferred. The priority attribute is only applicable to static routes and is configured under the advanced options on the guide. By default, all static routes have the priority of 0. Priority values are viewed in the static route configuration and on the routing table on the CLI, which you will learn later in this lesson. They are not displayed on the guide routing table. The priority attribute applies to which type of routes? Static. Which attribute does FortiGate uses to determine the best route for a packet? If it matches multiple dynamic routes that have the same distance? Metric. Which of the following route attributes that does not appear on the guide routing monitor? Priority. Equal cost multipath routing. Identify the requirements for equal cost multipath routing. Implement route redundancy and load balancing. If multiple routes of the same type have the same attributes, they can all be installed in the routing table and FortiGate can distribute traffic across all of them. So far, you have learned about the different route attributes available for routers to identify the best route to a destination. So what happens when two or more routes on the same type to the same destination share the same values for all the attributes? All routes will be installed in the routing table, and FortiGate will load balance traffic across all routes. This is called equal cast multipath. Equal cast multipath methods can load balance traffic using one of the following 4 methods. Sessions can be balanced among equal routes depending on the source IP address, source and the destination IP addresses, route or interface weights or interface volume thresholds. When using the source IP method, all traffic originating from the same source IP is expected to use the same path. The source destination IP method works similarly, but it also factors in the destination IP. So sessions from the specific source to a specific destination are expected to use the same path. With the ECMP load balancing method set to weighted, FortiGate distributes sessions with different destination IPs by generating a random value to determine the route to select. The probability of selecting one route over another is based on the weight value of each route or interface. Higher weights are more likely to be selected. There is an additional method called usage-based. In usage-based load balancing, FortiGate uses a primary route until the traffic value threshold is reached. After that, it uses the next available route. If one of the ECMP routes falls and is removed from the routing table, the traffic will be routed over the remaining routes. There is no specific configuration necessary for route failover. Configuring ECMP. The ECMP method is set on the CLI. For weight-based ECMP, weight values are configured per interface per route on the CLI. For spillover, ECMP spillover thresholds are configured per interface on the CLI. FortiGate uses source IP based on as the default ECMP method. You can change the settings on the command line interface using the commands shown on this slide. For spillover based equal cost multipath method, you must configure additional settings at the interface level. For weight based ECMP, you must assign weight values to interface or routes, or you can do this command line interface using the command shown on this slide. In the scenario shown on this slide, FortiGate has 2 equal candidate routes for the 10.0.4.0/24 subnet using port 1 and port 2 respectively. Using the default source-based ECMP method, FortiGate may use either route to deliver traffic destined for 10.0.4.0/24 subnet from user A and user B. If port 1 loses connectivity, FortiGate will automatically use port 2 to deliver all traffic destined for the 10.0.4.0/24 subnet. Equal cast multipath allows you to maintain multiple links for the same destination, as well as provide the built-in failover. This can be deployed for any network resources that have high bandwidth demands and are mission critical. Employing ECMP for these resources allows you to aggregate the available bandwidth for multiple links and load balance traffic across those links. When using equal cost multipath, you must have the proper firewall policies in place to allow traffic to egress all interfaces participating in ECMP. While you can use ECMP to maintain multiple internet connections on FortiGate, it can be more efficient to use software-defined WAN features to accomplish this. You can still use ECMP for internal resources. What is the default ECMP method on FortiGate source IP? How does the FortiGate load balance traffic when using the spillover method in ECMP routing? Sessions are distributed based on the interface threshold. Reverse path forwarding. Identify how FortiGate detects IP spoofing, block traffic from spoofed IP addresses, differentiate between and implement the different RPF check methods. Reverse path forwarding. Packets are sometimes dropped or for routing and security reasons. Reverse path forwarding is a mechanism that protects FortiGate and your network from IP spoofing attacks. It checks if there is a route back to the packet source. This check is run on the first packet of any new session. There are two reverse path forwarding methods, loose and strict. In the scenario shown on the slide, incoming internet traffic arriving at WAN 1 will be accepted because the default route is a valid route back to the source. However, there is two interfaces that will not route some incoming traffic port 1 and WAN 2. Port 1 will not route traffic because the subnet for user C is 10.0.4.0/24. There is no active route for that subnet through port 1. So traffic coming through from 10.0.4.0/24 to port 1 will be dropped because it failed the RPF check. The other interface that will not route traffic is WAN 2. While WAN 2 is physically connected to the internet, the only IP addresses that are valid as source or destination for WAN 2 are those in the 10.0.2.0/24 subnet. So incoming traffic from any other source will not pass the reverse path forwarding check and will be dropped. RPF checking. So how can you fix this problem? The first problem is fixed by adding a static route to 10.0. The first problem is fixed by adding a static route to 10.0.4.0/24 through port 1. Now, when FortiGate runs the RPF check for user C's packets, it finds the active route to the subnet through port 1 and the packet is accepted. The second problem is also fixed by adding a static route. In this case, it will be a default route for WAN 2. The second default route needs to have the same distance as the default route for WAN 1. This will ensure that both routes will be active in the routing table. They both can have different priorities, but they must have the same distance to be active. This is an example of when two routes with the same distance but different priorities are required. So one route will be the best. The one will be the lowest priority, but both will be active. The best route will be used for outbound traffic, but both can receive incoming connections without following the RPF check. RPF can either strictly or loosely enforced. In loose mode, the packet is accepted as long as there is one active route to the source IP through the incoming interface. It does not have to be the best route, just an active one. In strict mode, FortiGate checks that the best route to the same source IP address is through the incoming interface. The route not only has to be the active, but it also has to be the best. RPF checking can be disabled in two ways. If you enable asymmetric routing, it will disable RPF checking system-wide. However, this reduces the security of your network greatly. Features such as antivirus and IPS become non-effective. So if you need to disable RPF checking, you can do so at the interface level using the commands shown on this slide. In this example shown on this slide, 10.0.4.1 sends a sync packet to 10.0.1.2, but spoofs the source IP of 10.0.1.1. This makes the packets appear to be initiated from the internal network behind port 1. Loose RPF allow this traffic because the active route on WAN 1 is the default route. Next, 10.0.1.2. User B would send the sync acknowledgement packet to the real device with the IP address of 10.0.1.1. User A. Since 10.0.1.1, user A is not expecting any sync acknowledgement packets because any sync acknowledgement packets because it has not previously sent any sync packet to the 10.0.1.2, it will reply with the RST packet. So what happens in the same scenario when strict RPF is used? Strict RPF drops the sync packet even though the WAN 1 default route is an active route for the 10.0.1.0/24 subnet. It's not the best route. The best route is through the port 1 interface because it has the lower distance value. Remember, the default distance value for directly connected routes is 0, which is lower than the default route's distance value of 10. As the strict RPF strict RPF drops the sync packet, even though the WAN 1 default route is an active route for the 10.0.1.0/24 is not the best route. The best route is through the port 1 interface because it has the lower distance value. Remember, the default distance value is directly connected routes is 0, which is lower than the default route's distance value of 10. Although strict RPF is more secure, it can cause false positives if you use dynamic routing. Dynamic routes can change quickly. They could cause FortiGate to drop legitimate packets each time the preferred route changes. In general, it is recommended to use loose RPF in combination with firewall policies that block spoofed traffic instead of using strict RPF for that purpose. What is the default RPF check method on FortiGate? Loose. Which of the following route lookup scenarios will satisfy the RPF check for a packet? Routing table has an active route for the source IP of the packet. Best practices: configure the link health monitor, implement route failover, apply network design best practices, apply static route configuration best practices, use the forward traffic logs. When using an equal cost multipath routing, you don't have to implement anything extra for the route failover. Because of the design of equal cost multipath, route failover happens automatically. How do you implement route failover when you are not using equal cost multipath method? Link health monitor is a mechanism for detecting when a router along the path is down. It is often used where there are redundant routers on site, such as the dual ISP links when configured. FortiGate periodically sends probing signals through one of the gateways to a server that acts as a beacon. The server can be any host that should normally be reachable through the path. Usually, it's best to choose a stable server with robust infrastructure and to choose the protocol to which the server would normally respond. If the FortiGate stops receiving a reply from the server, all the routes using the gateway will be removed from the routing table. Alternatively, you can configure the device to administratively bring down on the interface, so all routes using the interface will be removed. While a monitored route is removed, FortiGate will continue to send link health monitor signals. As soon as FortiGate receives the reply, it will reactivate the associated routes. It may be useful to choose a server that is indirectly attached, located one or two hops beyond the FortiGate's gateway. This does not exactly test availability of this one gateway, but rather the combination of gateways. That way, FortiGate will accurately indicate availability of services and subsequent hops. Link health monitor configuration. The link health monitor is configured on the command line interface. You must set the egress interface, the IP address of the gateway router, and the IP address and the protocol. You need to enable the update static route setting to ensure that the FortiGate removes any matching static route. In the event link health monitor detects outage. This will allow any secondary route configured with a higher distance to be activated. You can configure multiple health monitors, for example, one for each ISP. Route failover example. In an example shown on this slide, FortiGate has two ISP connections, ISP1 and ISP2. Within each ISP's network, there are servers that the FortiGate is probing. Before failover, the WAN1 default route is active in the routing table since it has the lower distance. The WAN2 default route is configured with a higher distance and therefore standby. The link health monitor probes the ISP1 server located within ISP1 network through the WAN1 interface. When the ISP1 server does not respond to the probing attempts, FortiGate removes the primary route from the routing table. And because there is a second default route through WAN to activate it to route traffic to the internet. In this dual ISP scenario, your first reactions might be to implement equal cost multipath routing. After all, equal cost multipath would follow you to utilize both ISP links at the same time, which increases the available bandwidth for internet traffic. However, it may not always be feasible to implement equal cost multipath. Most of the time, it is related to cost considerations. The secondary ISP may be charging based on bandwidth or data usage. This is where you can use the distance attribute the conjunction with link health monitoring to implement route failover. Routing best practices start at the network design phase. One of the biggest challenges with static routing is figuring out how to handle discontiguous networks. While dynamic routing protocols are better equipped to handle them, they still create issues with large routing tables and route summarization. In some situations, you will not be able to handle discontiguous network with static routing alone. You may need to resort to NAT to allow traffic. Another challenge is to consider is asymmetric routing. Asymmetric routing is a situation where packets in the same session might flow through different routes to reach the destination. So, if multiple paths exist in your networks for the same destination, consider using the distance attribute to ensure only one route is active at a time. You can also consider using ECMP. However, the effectiveness of this will also depends on or whether or not the remote inside router is also capable of ECMP on some form of session persistence. In other words, the remote side router will also need to send the reply packets back through the same path. While FortiGate can be configured to allow asymmetric routing, it is highly discouraged to do so. Enabling asymmetric routing disables FortiGate's stateful inspection capability. Antivirus and intrusion prevention will not be effective because the FortiGate will be unaware of sessions and treat each packet individually. Disable RPF check at the interface level. Best practices configurations. If you find yourself creating multiple host routes, investigate whether you can summarize them in your subnet. Dynamic routing protocols are designed to summarize contiguous networks to keep routing tables small, reducing the size of routing updates and the time to do a route lookup. You should employ the same methodology when creating static routes. When configuring policy routes, treat them as an exception to the routing table. If you find yourself continuously having to create policy routes, you should re-evaluate your static route configuration to see if you can make adjustments there first. Remember, policy routes override the routing table. So the only way to override a policy route is by configuring another one. If you don't plan your policy route configuration, it can quickly become an issue. Also, large policy route tables are difficult to troubleshoot. Finally, if equal cost multipath routing is not possible with multiple routes, use this link health monitor in conjunction with the distance attribute to ensure you have route failover. If you enable the destination interface column in the forward traffic logs, you can view the egress interface for traffic passing through the FortiGate. The information can be used to determine which route is applied to which traffic stream, as well as identify any routing configuration issues. If your firewall policies do not have any security profiles applied, you should enable logging for all sessions in your policies. Otherwise, FortiGate will not generate any FortiGate traffic logs. Use this feature with some cautions, since establishing all sessions logging can generate a lot of logs if the firewall policy is handling a high volume of traffic. You should enable if necessary and disable it immediately afterwards. What is the purpose of the link health monitor setting update static route? It removes all static routes associated with the link health monitor's interface. When using link health monitoring, which route attribute must also be configured to achieve route failover protection distance. View active and inactive routes, view policy routes and the CLI. Use the built-in packet capture tools. Active routes. The command line interface command shown on this slide displays all active routes in the routing table. The leftmost column indicates the source of the route. The route attributes are shown inside square brackets. The first number in the first pair of attributes is distance, which applies to both dynamically and static routes. The second number is metric, which applies to dynamic routes only. Static routes can also have priority and wait attributes, which are shown as the last pair of attributes for the respective route. This command doesn't show standby or inactive routes. For example, when static routes to the same destination subnet have different distances, the one with the lower distance is considered active and thus is installed in the routing table. The one with the higher distance is considered standby and therefore not installed in the routing table. So this command displays only the one with the lowest distance. Active and inactive routes. If you want to display standby or inactive route using the CLI command shown on this slide, in this example shown on this slide, you can see that the command shows one standby route. The route is standby because the default route over port 1 has lower distance. The output also shown as inactive routes. Routes are marked as inactive when where the corresponding interface is administratively down or has its link down, or when the gateway is detected dead by link monitor feature. Policy routes and static routes created using ISDB addresses are not added to the routing table. They are added to the policy routing table. These routes can be displayed using the CLI command shown on this slide. The command lists all the active routes in the policy routing table. Packet capture or sniffers are one of the most useful sources of information for debugging routing problems. FortiGate includes a built-in traffic sniffer tool. It can be used to verify ingress and egress interfaces of packets as they pass through. The built-in sniffer can be run from either the graphical user interface or the command line interface. The syntax of command line interface command is shown on this slide. The interface is the name of the physical or logical interface. If your account has the access profile superadmin, you can specify any to capture on all the interfaces. If you are using any option, just remember that the sniffer will not print any interface MAC addresses. The filters are similar to TCP dump on Linux. You should configure specific filters to ensure you are only capturing when you need. You can also specify a count value to automatically stop the sniffer after capturing a specific number of packets. Otherwise, the sniffer will continue to capture packets until you manually stop it using Ctrl+C. The timestamp option can be used to print the timestamp information, used to print the absolute timestamp or lowercase to print the local time zone based on timestamp. Timestamp information is particularly useful when correlating sniffer output to debug flow messages. You will learn more about debug flow later in the course. By default, the sniffer uses the maximized transmission unit configured on the interface. Using the frame size argument, you can specify the length larger or smaller than the interface maximized transmission unit. If you use any interface, the sniffer will default to 1600 bytes. The verbosity level specifies how much information you want to display. There are 6 different levels. There's this table which once displays the IP headers and packet payload, Ethernet headers and interface names. Verbosity level 4 is used to take a quick look at how the traffic is flowing through FortiGate. If packets are arriving and how FortiGate is routing them out. Level 4 can also be used to easily check if FortiGate is dropping packets. Verbosity levels 3 and 6 provide the most output. Both show the IP payloads and Ethernet headers. You can save the output and export it to a packet capture file using a Perl script. The PCAP file can then be opened with the packet analyzer, such as the Wireshark, for further investigation. The Perl script that converts the sniffer output to PCAP can be found on the Fortinet knowledge base website. Packet capture examples. This slide shows 2 examples of packet capture output. The first example captures all traffic to and from port 443. It uses verbosity, so the information is easy to read. It displays 1 line per packet containing the incoming and outgoing interface, IP address, port numbers, and the type of packet. The second example captures all ICMP traffic coming through from or going to the host 192.168.1.254. In this case, the verbosity is 3, which is longer and more difficult to read, or as it includes the IP payload of the packet. However, this is one of the 2 verbosity levels to use, 6 being the other one, if you need to export the output to the Wireshark. If your model of FortiGate has internal storage, you can capture packets on the guide. The options are similar to those for the CLI. To run a trace, specify the source, interface, and a filter. What is the main advantage of using the GUI over the CLI? You download the output in the file format, PCAP, that is ready to be opened using Wireshark without having to use a conversion script. Regardless of which method you use, CLI or GUI, packet capture filters should be very specific to make sure only the relevant packets are captured and large amounts of data are not being written to the disk. What is the distance value for the following route? 110. Which of the following CLI commands can you use to view inactive routes? Get router info, router table database. Which CLI packet capture verbosity levels with interface names? 4.